Okay, continue to chapter 3. This is about orthographic projection. The topics today is about object representation, multi-view projection, glassbox concept, and then orthographic projection of point, line, plane, surface, and object, and then line convention. The object representation, for example, we have here like this. This is axonometric projection, then multi-view projection. The right side is a multi-view projection. Multi-view projection, three principal dimensions of an object. For example, we have width, depth, and height can be represented only two in each view, like this. This is represent the height and width, and also depth. We have two views in the right side here. Adjacent views is needed to fulfill the size description. You see here, depth in the top view and right view is the same. To obtain multi-view representation of an object, at first, revolve the object with respect to observer, and then the second, the observer move around the object. For example, revolve the object. From this position, you can revolve the object like this, then you will get the front view. And then revolve the object, then you will get side view like this. And then is this one, revolve the object, and we will get the top view. And the second method, the observer move around the object with the virtual plane like this. We see the face like this, and then you will get front view, and the observer move to the side right, and then see the object to right side view, move to the top of the object to get the top view. Then this method is called the glassbox concept. We see the different view and every side, and then the glassbox here we can make it open to this position. Then we will get in every view, for example, bottom view, left side view, rear view, and all views of the object. You can see this is the history, how to get the projection view. And then if we draw in here, all projection view is appear in here. This is the height, same with width, and also the depth, same with this one. And then the orthographic projection of object features. Edges are lines that represent the boundary between two faces. For example, we have two faces here, and we get edges in here. So we see we have three edges. How about the cylinder? Cylinder have edge as a circle here. How about the type of this one? There is no edge because only one face in here. Corner represent the intersection of two or more edges. We have three edges, so here we get one corner in here. For the cylindrical, no corner, and then this one, no corner as well. Surface are areas that are bounded by edge or limiting element. This is surface, surface, and surface. Limiting element is a line that represents the last visible part of the curved surface. You can see in the cylinder, it's mean the limiting line or limiting element. As well for this object, this is the limit line. And then the projection of point, for example, we have point A in here, then will be projected to another face. We have EF as a front and ER for right, and ET for top face, and then PT for the another point B. And also for the point A to B as a line here, we have a line E and B. We will get the projection as a point and also line on every face in here. How about the line with the angle? For example, we have EB here. Then we will get another projection with the difference length from the original line. This is the true line on the top projection. And then for the other is difference with the original line. And then for another position of line here, AB, when we project it to another face, then we will get not same with the original line. And then the projection of plane, for example, we have triangle A, B, and C. To the front, we will get line, and the right as a line, and for the top projection, we get triangle. When the plane is moved to this position, and then the projection should be like this. We don't have any same triangle for all projection. And then another position of triangle here. Also, we will not get the same triangle in all projection. The views are obtained by projecting all object features to the picture plane. For example, this one, this one, this one. You have to project the remaining surface with an invisible tool by using dashed line. For example, this object, you will get the projection be like this, and this one is projected like this. And then about the line convention, precedent of coincide line, hidden line drawing, center line drawing, precedence of line, for example, the order of importance, this is visible line, hidden line, and center line. For example, we have the projection view like this, then we want to make a hidden line in here, but we have a visible line, so we can use the visible line on the another projection, then remove the hidden line. And also for the center of circle, or the center of hole in here, we have another hidden line. For the top view, we have hidden line, center line, and visible line with the same position. And then hidden line practice here, hidden line should join at a visible line except it extended from the visible line. For example, this object is viewed from here, then we will get this projection and another hidden line. You see, should be joined and leave space on another position. This one is not correct. Hidden line should join a visible line except it extended from the visible line as well. For example, this one, we have a hidden line. So leave space here. This is correct. This is not correct. Hidden line should intersect to from L and T corners. For example, we have hidden line like this, so it should be connected. That's the correct, but when you make it space is not correct. Hidden art should start on a center line. For example, here, start from center line. Centerline practice in circular view, so that should cross at the intersection of center line. You see, this is the center line, and also this one is center line. For the small hole, center line is presented as thin continuous line, for example. And center line should not extend between views, so leave space between views. Leave the gap when center line forms a continuation with a visible or hidden line. You see, leave space here. Center line should always start and end with long dash. This is long dash. Okay, this is the assignment number 3. Draw the figures in E4 paper, and then you should use a purple scale. Upload your job through Schoology. You have 3 figures here, or 3 projection view here. Just draw as here, you see that this is a front view, right view, and top view. Use all elements, the object lines, hidden lines, and then the center of circle, and also the dimensions.